Hi everyone, today we're going to be talking about arithmetic sequences. So arithmetic sequences are basically a set of numbers that have a pattern, and the pattern is adding or subtracting something. So for example, something like 2, 4, 6, 8, 10, ... That is considered an arithmetic sequence because every time we're adding 2. From 2 to 4, we add 2. From 4 to 6, we add 2. From 6 to 8, we add 2, and so on and so forth. It would work the same way if we were subtracting something. So if I had, let's say I had 7, 4, 1, -2, ... Each time I'm subtracting 3. So that is also considered an arithmetic sequence. What we're going to do in this video is figure out if a sequence is arithmetic, and then determine what it's adding or subtracting every time, and find specific formulas for it. So let's go ahead and get started with the examples. For the first example, the sequence is 4, 6, 8, 10, ... So the ... at the end just means that it goes on forever. I could continue to write it forever and ever, but we don't have time for that. So for this example, what we're going to do is start by deciding if the sequence is arithmetic. So to determine if it's arithmetic, we have to figure out if it's adding or subtracting something every time. The way I like to do that is I like to kind of think, okay, from 4 to 6, what am I adding? So to get from 4 to 6, I would have to add 2. Now what we're going to do is decide from 6 to 8, are we adding 2? From 8 to 10, are we adding 2? Yeah, so we're adding 2 every single time, which means that this sequence is considered arithmetic because we're adding the same thing every time. So the next step of this example is to decide what the common difference is. So the common difference is what you're adding or subtracting every time, which we've kind of already done that. We already know that we're adding 2 every time, so my common difference, which I can call just D, is equal to 2, because that's what I'm adding every time. Then the next thing that it wants us to find is the next 3 terms of the sequence. So the next 3 terms of the sequence, it means like if I continue, if that ... wasn't right there and I just continued it for 3 more terms, what would happen? So I like to kind of start, well, I already have 4, 6, 8, 10. Those were what was given to me. If I were to continue, I'd have to add 2. So 10 plus 2 would give me 12. And then we add 2, excuse me, we add 2 to that. So we'd get 14, and then we'd add 2 to that, which gives me 16. So my next 3 terms are this 12, 14, 16. And then the last thing we're going to do for this example is find the 23rd term. So to find a specific term, there's 2 different ways you can do this. The first way is you could continue to write out numbers and add 2 every single time until you get 23 different numbers, and that 23rd number is your answer for the 23rd term. So that works, but sometimes it's going to ask you for maybe the 75th term or the 101st term, and so we want a better option. We want an option that won't take as long to write out that many terms. And the other option is to use this formula. So the formula is A sub n is equal to A sub 1 plus D times n minus 1. And let me explain what all of those mean. So this A sub n is the term we're trying to find. So in this case, it's the 23rd term. We want to find the 23rd term. And A sub 1 is your first term, so the very first thing in your sequence. In this case, it would be 4, because 4 is the first number they gave us. This D is the common difference. So remember, the common difference is what you're adding or subtracting every time. And then the last variable on here is your n, and n is the number of terms you want. So in this case, we wanted to find the 23rd term, so n would be 23. So now what we're going to do is kind of replace everything that we can. So A of n, I'm going to leave as A of n. I can actually put it as A of 23 because I'm trying to find the 23rd term. Then A sub 1 is my first term. Well, we decided my first term is the first number in the sequence, which is 4, plus D. So D is that common difference. We found that to be 2. And then n minus 1, we wanted to find the 23rd term, so I'm going to replace the n with 23, and then minus 1. Okay, so now that we have this, what we're going to do is we're just plug that into a calculator. and I end up with 48, which means that if I continued that sequence on for 23 terms, the 23rd term would be 48. Okay, so that's everything we have to do for this first example. Let's do it again for the second example, which will be slightly different. So the second example is 5, -3, -11, -19. Okay, so the first thing we're going to do is decide if it's arithmetic or not. So to do that, we're going to figure out, well, to get from 5 to 3, what did I have to do? So to go from 5 to 3, I subtract 8. That one's kind of tough because it's going from positive to negative. But the easiest thing, honestly, is to count on your fingers. But the other way you can do that is you can always do the second term minus the first term. And that'll give you what's happening or what you're subtracting. So in this case, it would be like -3 minus 5, which gives me -8, which is that's what I told you, it's subtracting 8. So now from 3 to -11 is also subtracting 8. And then -11 to -19 is also subtracting 8. I know right here I said second term minus first term, but you could also, just to double check, you could do the third term minus the second term and the fourth term minus the third term and make sure they all get -8s or -8s. Sorry, and there should be a ... here. So because we're subtracting 8 every single time, that means we know it's arithmetic. And because it's arithmetic, we have to find the common difference. So the common difference is what you're adding and subtracting every time. We already figured that out. We're subtracting 8. So we're going to write -8 right here because we're subtracting 8. Then the next step is to find the next 3 terms. So if I have -19, what I'm going to is my last term that was given. I'm going to do -19 minus 8, and I'd get -27 as the next term. Then I'm going to subtract 8 from there, and I get -35. And then I subtract 8 from there, and I get -43. So these are my next 3 terms. Then the last part of this is to find the 23rd term. Once again, you could continue to write this out, continue subtracting 8 until you have 23 terms, but we're going to use that handy-dandy formula, which is a sub n is equal to a sub 1 plus d times n minus 1. So we're going to find the 23rd term again, so it's going to be a of 23 is equal to a of 1, which my first term. So my first term in the sequence was 5 plus d, which is my common difference. That's -8. I'm going to just put it in parentheses. And then n minus 1, the n, because we're trying to find the 23rd term, should be 23. Okay, now we're going to plug that into a calculator. And I get -171, which means my 23rd term is -171. Okay, so now let's move on to the next 2 examples, which are slightly different. The third example is the sequence 18, 23, 28, and 33. And what they want us to do is find the explicit formula and the recursive formula. So the easiest way to do this, I'm going to write out those formulas for you, but the easiest way to start out is to find the common difference. So we're going to go from 18 to 23. Well, what am I adding? I'm adding 5 right there. From 23 to 28, I'm adding 5. From 28 to 33, I'm adding 5. So of course we know it's arithmetic because we're adding the same thing every time, and we know that d is equal to 5. So that's going to help us out. Let me write out these formulas. So the explicit formula we already actually learned, and it's a sub n is equal to a sub 1 plus d times n minus 1. Now in this case, we're not replacing the n with anything because we're not trying to find a specific term. We're just going to leave the n as is and replace the a sub 1 and the d because we do know what those 2 things are. So I'm going to write it as a sub n is equal to my first term. Well, my first term in the sequence is 18 plus my d. Well, my d is what we're adding every time, so that's a 5. And then n minus 1. Remember, we're not replacing the n because we're not trying to find a specific term. We're just using this as a formula. And we can actually simplify this a little bit. We can distribute this 5 inside the parentheses, which would give us 18 plus 5n minus 5. And then we can combine these like terms, which would give me a sub n is equal to 5n plus plus 13. So this is my explicit formula. And I can use that explicit formula to find any term in the sequence. So if I said find the 51st term, I would just replace the n with 51. If I said find the 1,000,000th term, I would replace the n with 1,000,000. Okay, now we also need to find the recursive formula. So the recursive formula is a little bit less, it's not used as often because it's a little bit harder to find specific terms, but the formula is a sub n is equal to a sub n minus 1 plus d with a sub 1 is equal to first term. So the recursive formula, what you have to have is you have to know the term before it. So if a sub n, if we want to find a sub n, we have to know a sub n minus 1. And a sub n minus 1 is the term before a sub n. So for example, if I was trying to find the 5th term, I would need to know the 4th term. This is why the recursive formula isn't used as often, because if I wanted to find the 100th term, I would need to know the 99th term. But in order to know the 99th term, I'd have to know the 98th term. And we'd have to continue to go backwards until we were just finding every term anyway. So on this one, we really just have to still replace the d in the a sub 1. So on here, I'm going to say a sub n is equal to a sub n minus 1. So all of that stays the same, plus your d. Well, we decided d was 5. And then we would say a sub 1 is equal to 18. You have to have that a sub 1 is equal to 18 because you have to have somewhere to start. You have to know that what the first term is in order to be able to find the second term, in order to be able to find the third term, and so on and so forth. So those are your explicit and recursive formulas. Let's do one more example with that. So the last example, the fourth example, has the sequence 10, negative 1, negative 12, negative 23, ... Okay, so once again, we're going to find the common difference first because that's going to be it's going to make it easier to find those two formulas. So to go from 10 to negative 1, we subtract 11. Negative 1 to negative 12, we also subtract 11, subtract 11. And so we know that our common difference is minus 11. We're subtracting 11 every time. Now let's start with our explicit formula, which is a sub n is equal to a sub 1 plus d times n minus 1. We're not replacing the n's, but we are going to replace the a sub 1 with our first term, which is 10, because that's just the first number that comes in the order, plus your d. Your d is negative 11, so I'm going to replace that d with negative 11, and then n minus 1. This is fine, but we can simplify by distributing the negative 11, which would give us 10 minus 11n plus 11, and then we can combine like terms, which would ultimately give us the explicit formula of a sub n is equal to negative 11n plus 21. So there is our explicit formula. And now let's find the recursive formula, which once again is a sub n is equal to a sub n minus 1 plus d with a sub 1 is equal to the first term. Okay, so without replacing the n's, we'd have a sub n is equal to a sub n minus 1 plus your common difference, which is negative 11. And then a sub 1 is equal to your first term, which in this case is 10. Now I can simplify that a little bit by just taking the negative 11 out of parentheses and saying a sub n minus 1 minus 11. And then a sub 1 is equal to 10. But either way it'll work. And there's our recursive formula. So that is how we deal with arithmetic sequences.